So now I would like to introduce our next guest, Simona David, who is a security research engineer at Keysight Technologies. She has an awesome presentation on adversary emulation on Windows. I'm really looking forward to it. So please, give her a warm welcome. I know we can't applaud speakers online, which sucks, but still, Simona, I want you to know today that my energy is with you, and I bet that I am not alone. So welcome to DefCamp.
Hello, my name is Simona. I am a security researcher within Keysight's Application and Threat Intelligence Research Center. Here we try to reproduce attack techniques in a safe environment, and we come up with new vectors of bypassing current protection mechanisms. I very much enjoy playing in CTFs, and I suggest you enroll in the Defend the Castle competition hosted by my colleagues. You can also find me on social media. I trust your awesome skills. And we can also talk in the Keysight virtual booth. This presentation will focus on adversary emulation, mainly on the ways in which we can automate and emulate the techniques used commonly in the wild by malicious actors. We will start by defining the terms, understanding the difference between pen testing, red teaming, and adversary emulation. We will talk about the Mitre Framework and how we can use it to our advantage. And lastly, we will go through some examples and how they were implemented by us. The first term we want to define is penetration testing. It is a simulation designed to check for exploitable vulnerabilities, its goal being to find as many vulnerabilities in the time allotted. The team has a defined scope, like a web application, server, or an API, and a defined time frame, usually a few weeks, depending on how big the scope is. Those are agreed with the customer beforehand. Usually it is limited to network or application layer exploitation, but sometimes it involves social engineering as well. The next term is red teaming. Red teaming is an exercise designed to measure how well the security controls can withstand an attack. The goal is to test the organization's detection and response capabilities. The scope is larger than the one of the pen test, and the time frame is bigger as well. The scope is basically everything from infrastructure to people to physical locations. With a larger scope, the tactics are more. The first tactic, social engineering. Because with a little bit of research on individuals and organizations, phishing emails become a lot more convincing. This low-hanging fruit is frequently the first step in a chain of attacks that lead to the goal. Network service exploitation. Exploiting unpatched or misconfigured network services can provide an attacker with access to previously inaccessible networks or to sensitive information. Usually, attackers will leave a backdoor just in case they need access in the future. But we've also seen cases where they patch the system so that other competing attackers will not use the same method. Physical facility exploitation. As with social engineering, attackers will choose the weakest link, humans. We have a natural inclination to avoid confrontation. Thus, gaining access to secure facility is often as easy as following someone through a door. The next tactic, application layer exploitation, because web applications are often the first thing we see when researching an organization. Exploiting web application vulnerabilities like cross-site scripting, SQL injection, or cross-site request forgery can give an attacker a foothold from which to execute further attacks. Adversary emulation is a part of our red team simulation. The goal is the same, to measure how well the security controls can withstand an attack. It mimics the behavior of an attacker because we want to make it look like a real attack is happening while there is no real adversary. We simulate the behavior in all the stages of the attack, from the enumeration step to the final objective, being it exfiltration of data, encryption of data, whatever their objective might be. We make use of their tactics, techniques, and procedures to mimic their behavior as much as possible. But how do we know how attackers behave? How do we know how they go undetected for such long periods of time? The answer is quite simple, the Internet. Mitre is a collection of TTPs used by attackers. The Mitre content is based on real-world observations, being a guide of techniques used by attackers. This allows us to understand their behavior and prepare our defense. The framework introduces some concepts, and we will go through some of them. Domain refers to the enterprise, mobile, or industrial control systems domain. Tactic refers to the objective of an action. What is the goal? An example is privilege escalation. An attacker is doing this action to gain higher level privileges. The technique represents how the tactical goal is achieved. An example is that adversaries may establish persistence and elevate privileges by executing malicious content triggered by a Windows Management Instrumentation event subscription. Mitigation represents security concepts and technologies that can be used to prevent a technique from being successfully executed. Group refers to a set of related intrusion activity that are tracked by a common name in the security community. And data sources represent the various subjects, topics of information that can be collected by sensors or logs. This is an example of how a technique looks. We see that the domain is enterprise. The tactic is discovery, and it's intended to work on Windows. We see some mentions of groups and tools that make use of this technique, with some mentions of Windows commands like gpresult. Let's imagine now that we work for a healthcare company in a very small security team. Ideally, we would have the time, people, and budget to perform penetration tests on our platform. Given the high number of attacks against healthcare companies in the last 2 years, given the pandemic context. In reality, we won't have much of that, and we have to make a compromise. Based on threat intelligence, we determine which groups are most likely to target our organization. We emulate this adversary, we mimic their TTPs, and we test those in our environment. Is this the perfect scenario? No, but it is better than doing nothing. But how does the Mitre Framework help me as a security researcher? First, we need to understand the framework, how the data is structured, and what terminology they introduce. We need to look at the bigger picture. Why would an attacker perform this action? What are his goals? Is this action malicious by default, or is it malicious in that chain of events? When we research a malware campaign, we can map the actions to a tactic and technique and split each stage into smaller steps. For example, when a docx file is sent to a user, what is the usual user behavior? Why would an attacker send that file? Are we worried only because a new winward process is started, or is there something else happening there? We have to be wary of our goals. We implement testing procedures that simulate real-life attacks. We need to have a good coverage for each technique in terms of actions. By improving our coverage, we improve the organization's detection capabilities. Also, these testing procedures do not include physical location tactics. We speak here only about things that can be translated in code. While performing the research, we start by choosing a technique. We have to understand how attackers use this technique to achieve their goals, and we replicate their behavior and create a test procedure while implementing. Going a bit in depth, I present you Conti, which is a ransomware as a service that has been used against organizations and government agencies in North America. The sample hash mentioned here is one recently seen in the wild. This campaign starts with the dangerous user behavior, simulating a user downloading a known actual malware executable from the internet. The executable, if run, would quickly infect the machine. Shadow copies will be deleted to prevent data recovery, and evasive techniques will be deployed to stay under the radar. Finally, the user's documents will be encrypted and the ransom note will be written to disk. So we can say that the campaign started with delivering the malware, installing it, the objective being to encrypt the user's data and ask for money in return. These three stages, delivery, installation, and objective, are part of the Lockheed Martin Cyberkill Chain represented on my slide in the right side. The first step is reconnaissance, where the attacker harvests information about the target. Next, we have weaponization, coupling exploit with backdoor into deliverable payload. Delivery. We deliver the weaponized bundle to the victim. Exploitation. The attacker exploits a vulnerability on the victim's system. Installation is a stage where the malware gets installed. Command and control represents a channel for remote manipulation of the victim, and the objectives is a step where the attackers achieve their goals. Going deeper, we break each stage of the Conti campaign into smaller actions, and for each action, we find a representative in the Mitre Framework. The delivery part is straightforward. The campaign begins with dangerous user behavior, simulating a user downloading a known actual malware executable from the internet, corresponding to T1204.001 Mitre subtechnique, which is user execution malicious link. The installation part is more complex because the malware does the following things: employs various anti-debug and anti-analysis techniques, and enumerates and deletes shadow copies. For each step observed in the execution, we assign a Mitre technique or subtechnique. The objective part is represented by data encryption, corresponding to T1486 technique, data encrypted for impact. We translated all these steps into actions, and we can simulate the chain of events, from the malware being downloaded to the data encryption. We run the simulation against the Windows setup, and we see that all actions are allowed, meaning that our security controls on that setup fail to protect us against this attack. Now we know that mitigation actions have to be employed to make sure that we can prevent such attacks from happening in the future. The sooner the chain of events is interrupted, the better. We've talked about the three stages and the actions in each of them. Let's dive deeper into one of the installation steps represented by T1082, System Information Discovery. From our research, the malware calls getWMI object using the Win32 shadow copy class. This class is a storage extent that represents a duplicate copy of the original volume at a previous time. This installation step uses Win32 shadow copy to retrieve the shadow copies available on the system. When running this step against our setup, we see that the execution is allowed, that our security controls fail to prevent this from happening. It's true that not any action is by default malicious, but it has to be correlated with other events on the setup. Now we will see what our test procedure does on the Windows machine. We will run the test procedure from a Linux VM to a Windows VM just for testing purposes. We'll see that our previous command will get executed and a new file will be created in a temp folder. We just ran the attack from our Linux VM to the Windows VM. We see that some steps are being performed on the Windows VM. We will talk about these steps later. And we see that our command gets executed, the getWMI object class Win32 shadow copy, and the new file named shadow copies was created in the temp folder. But calling getWMI object using the Win32 shadow class is just an example of how system information discovery can be achieved. Other tools and commands can be used to gather this type of data. For example, system setup can be used to gather this type of data on macOS systems, and it will display system data when run with privileged access. Also, infrastructure as a service cloud providers allow access to instance and virtual machines, virtual machine information via APIs. System info is a tool that can be used to display OS version as well as information on the system configuration, BIOS, motherboard, and processor. By using this technique, the attacker is trying to learn about the environment in an attempt to plan its next malicious activity, payload development, and concealment. As I've already said, these commands should not be viewed in isolation. They are not malicious by default, and they are part of a chain of malicious actions. So events on those Windows machines or machines in general have to be correlated. When researching a technique, we start by inspecting the Mitre page, going through all the commands and tools mentioned there, because the framework summarizes which tools were used by which threat actors. We have to know if the tools are present by default on the system, if the commands are native OS commands, and we have to test everything and see how the execution goes. After one command is successful, we have to ask ourselves what changed on the system. For example, was there any change in registries? Was there any file created? This will help us in two ways. First, cleaning up. We cannot run a test procedure against a machine and leave the machine in that state. We have to restore it to its initial state. So if a registry is modified because of our issued command, at the end of the execution, we have to restore the registry to its initial value. If a file is created, we have to delete it. And second, the changes in that machine state can represent an indicator of compromise. For our next demo, we will introduce T1221, template injection technique. We'll see how...
Thanks for sticking around with us. We had a minor mishap, but as demos always go. It was not the demo's fault though, but still, we're back. And Simona, take it away.
Yeah, thank you. As always, the demo gods are not with us. So back to our demo. We will introduce T1221 template injection. We will see how opening a docx file will result in remote code execution on the Windows VM. Before beginning, let's talk about the threat simulator terminology. In our case, each test procedure is called an audit. Each audit performs a series of steps, prerequisites, executor, and cleanup. In the prerequisite step, we account for all needed tools, files, and settings. In order to restore the value of a registry, for example, we have to know its state before running the audit, and we have to save it as well. The executor part accounts for the malicious actions like modifying the registry, and the cleanup part restores the initial settings. If something was modified during execution, we have to bring it back to its state before execution. If a file was created, we have to delete it. If a process has been created, we need to stop it. Now back to our demo where we will talk about T1221 template injection. Microsoft Office is the default application for docx suite. Is a favorite vector and target for adversaries to gain initial foothold in a network. Through social engineering, users can be manipulated through answering security prompts to enable macros, leading to remote code execution. Office Open XML is a format for Office documents that replaces older binary formats like doc, PPT, so on. The template inside the docx file resources and can be abused to execute code from the internet while the document is being loaded. This audit targets secure user behavior to enable editing and macros upon opening a Microsoft Office document and executing malicious code while loading the document. the insecure user behavior, we have to account for all the steps a user would take. So our test procedure performs the following steps. It will copy a docx file to the target machine, disables the protected use settings, enables enable all macros trust solve, and use Microsoft Office application, attempts to connect to the internet to load the malicious template that will execute calc.exe, closes this office, deletes this document, calculator application, and restores the original settings. This recording shows the procedure works as expected. We will see the following prerequisites will run on the machine, disabling the protected view in a resource docx file to the victim machine. It opens the file and the template inside the docx will try and load malicious code Nginx Container on my Linux VM. The code will open the calculator for Windows VM. This is just for the purposes point. So I started the attack against the Windows machine. Here we had some that the calculator file was added in the downloads folder. Now the port is opened, and we will see the calculator process being created. Each audit produces indicators of compromise. In our case, an indicator that the audit was executed successfully is a calculated process starting after the Word document is opened. This ensures that the insecure behavior was simulated correctly and the remote code execution happens. This audit will produce also Windows event logs in Microsoft Windows Sysmon operation. In the first event log, we see that a new WinWord process is created where it will open the docx file. Then we notice a network connection to our Nginx container where the template will be loaded. And lastly, we see a new process being created for the calculator app. Now for the conclusions. Pen testing, red teaming, and adversary emulation are all great. It just depends on what your goals are. Some governing authorities require pen testing, such as SOX and HIPAA. I recently read this blog post where the author compared penetration testers to pirates and red teams with ninjas, and I think this is very accurate. Each is useful in certain situations, and you wouldn't want one to perform the actions of the other. Since Mitre Framework is a collection of real-world adversary behavior, we can use those for emulating their behavior. The level of emulation depends on the organization. Not every company has a red team ready to test their defenses. If we are a small company, we can start by researching the threat actors and the techniques they used against organizations like our own. If we already have a red team capabilities, we can map our procedures to the Mitre framework and get a view of our coverage. What are we missing in our red team engagements? This coverage is built over time in techniques for Windows platforms, and recently we started researching techniques for Mac OS and Linux systems. We also pay attention to how the framework changes, what new techniques are added, because we want to constantly improve our coverage. This was my presentation. I hope you enjoyed it.
Thank you so much, Simona. And thank you for braving through the technical issues that we had. Unfortunately, like there was an internet outage, which, as I wrote on the chat, is actually, a good opportunity to remind ourselves why we're all trying to contribute to defending it and keeping it stable so that we may be able to share these things and work together and, do our work the best that we can. I have a quick question for you. What's the best part about working in cybersecurity research for you personally? Can you still hear me, Simona? Or am I a bit delayed?
For me, it's the each day novelty, the fact that I get to do what I like and learn from it. And yeah, now I can. Yeah, so for me, each day is the novelty and the fact that I get to do what I enjoy and I get to work with amazing people that like the same things that I do. And I feel like this community is, at least in Romania, is a small community, and we kind of each know the other teams. And I don't know, it's just I'm happy to do what I like.
I think that's really, really helpful to know. And yes, people make all the difference. That's why this conference is all about the people and their work, their passion, their commitment, and how everything comes together. So thank you so much for your presentation and for sharing all of this with us. I think that I wanted to take just a quick chance between presentations to go just a little bit into maintenance mode to make sure that the sound doesn't come through to everyone watching with tiny issues, and that we're fully back on track before we move on to the next presentation. So tech team, could we go to maintenance on track 1, please, just for a little bit? And thank you, Simona, once again. I hope you enjoyed the rest of the day. And again, thanks for braving through. The presentation is recorded and will be live on the YouTube channel, DefCamp's YouTube channel. So there's a chance to see it end to end again and dig into it once it's live there.
Thank you.